Hi, I'm Aya, and welcome to Mutations and Protein Synthesis. Also, you are a mutant. I know what you're thinking. What? I'm not a mutant. That's for teenage turtles and sci-fi movies. Well, guess what? I'm telling you that you are. We are. And not we as in just you and me, but we collectively, as in the entire human race and all of the species on Earth. Okay, let's back up. To understand how we're all mutants, we first have to understand how we live here in the first place. The answer lies in the central dogma of biology, also known as protein synthesis. Proteins are the basis of life. They form the structures in our bodies, help us maintain homeostasis, they regulate our body's pH levels, and come in delicious bundles of chocolate-coated, peanut buttery goodness. And this is how they're made. In normal protein synthesis, there are two main steps, transcription and translation. Transcription involves the creation of mRNA, also known as messenger RNA. This strand of information is just a copy or template of instructions that DNA holds in a living organism, which are the instructions to make proteins necessary for survival. The reason mRNA must exist is because DNA cannot leave the nucleus. The messenger RNA has to deliver the information to the ribosome to make the necessary proteins. During transcription, an enzyme called RNA polymerase attaches to the beginning of a sequence that codes for a protein. The RNA polymerase creates a single strand of complementary bases to one side of the DNA. After this happens, mRNA is still not mature enough to go through translation. Splicing and editing must happen first. Splicing is just the fancy term for removing parts of RNA called introns that do not code for the protein. The remaining exons are left alone. I remember this by thinking introns, in the trash. Exons, exit the nucleus to go towards the ribosome. Editing is when a few nucleotides in the mRNA are changed to ensure that the correct protein is made. You can think of this like editing a sentence in an essay. You might change one or two words to increase the clarity or better communicate what you're trying to say. Bob ate a sandwich, or Bob consumed a sandwich. Now that the mRNA molecule is ready, translation is exactly what it sounds like. In translation, the mRNA leaves the nucleus and is given a big hug by the ribosome, as tRNAs or transfer RNAs come to finish the job. tRNAs look like their name, the letter T. At the top of each, there's an amino acid. At the bottom, there are 3 bases. This trio of bases is called an anticodon. The sequence of bases in the anticodon determines which amino acid will be at the top of the tRNA. These bases connect to the complementary bases in the form of codons on the mRNA, making sure that the amino acids are in the order according to the original DNA sequence. When they're in this order, the amino acids form a long polypeptide chain that is then folded into a protein. Now, if there's a mutation in the DNA, the wrong information can be copied into the mRNA template, meaning that the information is translated into the wrong protein. Though this may seem bad, these mistakes in our DNA are what make us unique. Remember how I mentioned the fact that there are different species has to do with mutations? There are healthy mutations that make an organism more likely to survive and reproduce, and it is these mutations that allow different species to develop. Who knew being a mutant can mean the emergence of different species? Who knows, maybe in the future, humans will resemble the super creatures of your dreams, having pizza with larger-than-life karate reptiles. It can happen.